What? Oh. Oh, hey, it's Mr. Gubino here. Sorry. We're going to be talking about circles today, and just copy the notes down from Google Classroom, and we're going to begin. So I'm going to go over some definitions first. So this whole video will be about definitions, and then we'll get into the angles and segments that are involved with circles. For instance, central angles or angles that are inscribed or segment lengths within chords, things like that. All right, so let's get right into it. We're going to go over to the notes document camera here, and we're going to talk about circles. All right, circle. A circle. Not real too keen on the green right now. Let's see if we can go in on this. All right. Now it says 10.1 tangents to circles, but these are all the definitions. And generally what I would have you do is write out each of the definitions as we go. But to save a lot of time, I'm just going to do this and talk each one about each part to this. Okay? So by definition, a circle is a set of points an equal distance from a given point called the center. This point is A. In this circle, this is circle A. All points, including B, C, D, and E, are all equal distant away from A. Now, we will call this circle A by the center. So that is your center of the circle. There's an abbreviation. It is a kind of a dot inside of a circle that shows the center, which is A. And it said that B, C, D, and E were all the same distance away from A. Now, when I draw these, you should know by now what I'm drawing, and we'll talk about that in just a second. But each of those are a distance away, and there's an infinite amount of points on this circle, on the rim of that circle, that are equal distance away from A. For instance, if I had point A is a different distance away from this point as it is in this point, so that's not a circle. Okay? All right. The center of the circle, we just kind of talked about that previous. The point that all other points on the circle are equal distance away from. In this case, this is point F. We use the circle symbol to call a circle. So this would be circle F. And G would be equal distant away from F. Or we say that G is on circle F. We could write that as well. All right. Radius. You've probably seen two definitions of a radius. All right. Well, you may have seen only one. The first one is a segment that joins the center of a circle to a point on the circle. For example, you got HJ and HI. H to I, H to J. They are segments. We put the little bar over top, remember? Or a radius is the distance from the center of a circle to a point on the circle. So the distance would be HJ. The distance would be HI. If we put no symbol on top, no bar on top, then it's a distance. So that length, we would say that HJ equals the length from H to I because they are the same distance away because it's a circle. And let's just say this is equal to 5. So we would put maybe a 5 right there. Something along those lines. Okay, so we're going to go to the next page. All right, next is the diameter. And this one also has two definitions. So a diameter is a segment that joins 2 points on the circle. Okay, so P and L are on the circle, but it must pass through the center of the circle K. In other words, it is a chord, which we're going to talk about down here. So it's foreshadowing that word chord. that goes through the center of the circle. So for instance, we could say diameters are PL, or we could name it LP by a segment. Notice I do not need to put K in there because I'm naming the endpoints, the points that are on the circle. And it has to go through the center of the circle. So if I wanted to draw another diameter in here, all I have to make sure that it does is it goes through K and it hits the circle here. Let's call this D, and I can't call it that. Let's call it T. So another diameter would be DT or TD. Okay? It is also a distance from 2 points in the circle passing through the center. All right, also known as 2 radii. So if you notice, you have radius PK and radius LK. Well, if they have K in common and they go through this center, the diameter is PL. It is also a distance. So a distance, PL, let's say is 10. That means that P to K and L to K are going to be the same because these are radius lengths, and the radius is half of the diameter. The distance across the circle is equal to half the distance from the point to the center. Okay, hopefully those are things that you have already discussed in any math class that you have had, hopefully. Hopefully. All right, a chord, not a chord, a chord, kind of pronounced as C-O-R-D. All right, so a chord is a segment that joins, so a segment that joins 2 points on the circle but does not have to go through the center. So if it does go through the center, it's called a diameter because it is a chord that goes through the center. So remember our definition of a definition of a definition is that we need words to describe everything else. So a chord, first of all, is a segment that joins 2 points on a circle. A diameter is a chord. We know what a chord is now that joins 2 points on a. So over here we have several chords. We have, you don't have to name it like this. I'm just going to say, so if we have chords, we have BE, we have EC, we have CD, and we have BD. Now, those measurements could be a measurement as well, but a chord in this sense is only, in the circle sense, is that. Chord means something else in music. We're not going that route. So it is a segment. So it begins and ends on a point on the circle. And what you will learn is that if you have 2 chords and we do something to those chords, we can find the center if we don't have it. Okay? All right, so a secant line is a line, generally speaking it's more of a line, sometimes it's a segment that intersects a circle at 2 points. So if I simply just put an arrow on there, it's going through that circle. It's hitting the circle at G and Q. It must hit a circle at 2 points. It must be a line. It must be a straight alignment of points. We know that a line going through 2 points creates one line. Okay? So in this case, we could say that this is SR, is the secant. Starting at S, going to R. We can name S to G, S to Q. Again, S to G, S to Q. These are going to name the same segments because in a line, it doesn't matter which segment you name. Okay? So we have a chord. And a chord, if you notice, is part of a segment. You have a chord here, segment G, Q. That is a chord. So if I go from G and go to Q, That is a chord. So remember back to the definitions that we had, that a segment is a part of a line that I break off at the endpoints. So in this case, if I have the line SR or GQ, what I'm going to do is I'm going to break these off and create my chord. Right? Okay. So again, if you have to, turn back the play on this, go back through, read it or hear it again. Don't slow it down. That's rude. All right, so we're going to go to the next one, and we're going to get more in depth with these in just a moment. But the next one is a tangent. And a tangent, now tangent you have heard before. You have heard this in trigonometry, if you remember. And tangent is the ratio of the opposite side to the adjacent side, right? Well, tangent in this case is a circle. Pertaining to a circle is a line or segment in a plane that intersects the circle in exactly one point. So a tangent always has to be outside of the circle. Okay, so it has to be outside of the circle. So in this case, UT, I'm going to make it a line. I'm going to make this a line just by simply putting arrows on, is tangent to point or circle K at point P. So point P to K, P to K is, yes, a radius. And a tangent is that. Now we're going to find something out about the tangent. I'll just kind of tell you about it, and then we'll revisit it when we get to tangents. But a tangent is perpendicular to the radius. Okay. Now, when you're talking about tangents, what you have to think of is, let's say you were on the playground and you were going around the merry-go-round, or if you were at a merry-go-round at the fair, and that is turning. If when we jump off, I guess I can't say that. Let's do this. Imagine, if you will, if I stand at K and I swing my keys around my head on a string, and or a lasso, if you're a rodeo person, a lasso, and you let go of that, does the rope continue to go in a circular motion? Does it keep spinning above your head? So if I take that thing and I'm spinning it like this, okay, you can't see obviously, but if I slow it down, where is my end of my cord? If I let go, where's it going to go? Is it going to continue to do this? No, it's going to hit, and when I let go, wherever I let go, it's going to go straight in the direction that it was turning. So if I'm going like this and I hit this spot and I let go, it's going to continue on that way, straight. That's a tangent. It's not going to go and hit this spot and go, yeah, let's continue to go if I let go. It's going to go off straight as a vector into the area. Now, when it's going to start curving just because of gravity, but in that case, it's going to go straight. So there's an old, if you're on a date and you don't particularly like the person that you're dating and they're in your car and you're driving, you make a sharp, let's see, a left turn and make sure their doors open. Please don't do that, but they would go. It's just centripetal force. If you take a bucket of water and you swing it around your head, that's what keeps the water in, the centripetal force. Now, if you let go, obviously that water is going to spill on you if it's up in the air. Okay. All right, so let's move on. Mr. Goubinaux's rambling again. Here we have an example. So we want to identify special segments of here. So a chord. A chord is a segment that has its endpoints on the circle. So I need to look for points that are on the circle. So on, this is circle A. All right, so points on circle A are E, J, C, B, and I. Which one have segments going from endpoints? Well, C goes to B. C is one of them, or BC. And the other one, I, is on the circle, so it goes to J. Now, notice I did not write F because I want the segment. Yes, it's part of the segment. I can name that. Now, there are other ones that are not visible, but can be shown, like IE, BE, CE, and even JE are also chords. There's a chord right here that goes from I to that point right there. Well, JI is not only a chord, but it is also, because it goes through point A diameter. Okay. Secants have to go through 2 points on the circle. So I need on the circle. I need a line that goes through them, or a segment that hits the circle twice. Well, I see one here. It hits I and it hits this point right there. We don't know, but GH is a secant because it goes through the circle twice. Another one, BC would, if there was a point out along on BC, if I extended it, or through C. A to F. A to F is the other one because F is outside and it connects J to A to I. Now, the other part isn't out there, but we know that in a segment, this is part of a line that extends infinitely in that direction. All right, a radius. Well, you know, a radius goes from the center. So a radius has to have point A on it, and it has to go to a point on the circle. So a point to the circle, A to I, and A to J. Yes, we could have A to C, and A to B, and A to E. It's not drawn, so I'm just going to write the ones that are there. And the tangent has to hit the circle at 1 point, exactly 1 point. Well, the only time that a line hits the circle, this one hits twice, so that's the secant. This is a chord, this is a diameter or a chord, this is a secant. Here's my tangent. So in the tangent, you can go to H to F, you can go H to E, you can go F to E, E to F, E to H. It does not matter. Okay? So that's what we got going for us with chords and naming them. So there's a practice at the end of this packet. I'm just going to go forward to that just for 1 second. And here's some practice. So I gave you segments and these other little funny looking things, which I'm going to talk about here in a second. So that'll be homework as well, the last 2 pages. All right, so this is kind of other definitions that we need. We're just going to go over these and then I'll go more in depth with them a little bit later. So arcs and chords. Arcs and chords are an angle whose vertex is the center of the circle. So EAG is my central angle. A is my center. So A is the center. We would name this circle A. Thus we have radii. The plural for radius is radii. We would have radii AB, AE, and AG. We have a diameter in here of BG. Notice I do not have to write the A in the BG. So again, AB, AE, AG are radii, and the diameter goes from the 2 points on the circle through the center, so that is BG. All right, there are things called arcs, and arcs are portions of the circumference of a circle. So if you think about the circle, The circle is obviously a round object, so it's going from E along this little path, the outside of the circle where all those infinite amount of points are. And an arc is a portion, again, a portion of the circumference, fancy term for perimeter in a circle, of a circle. Okay, so an arc is a portion of the circumference of the circle. Circumference is the outer of the circle. So a side would be, that would be the side, same as a side would be the same as a portion of the perimeter. So a side, this side would be a portion of the perimeter. So the arc is a portion of the circumference of a circle. Okay? There are minor arcs, major arcs, and semicircles. All right, I think you know what semicircles are, but we'll come back to that. So a minor arc, not one that's under age 16. No, a minor arc is a smaller arc. The measure of the central angle. So again, a central angle is formed by taking any point on there, connecting it to the vertex, and then connecting it to another point. Just forming an angle. It could be obtuse, it could be acute, and in some cases it might be greater than 180. Again, we won't deal with, none of your answers will be more than 180. We just want you to be aware, or I just want you to be aware that it could happen. Okay? So a minor arc is the measure of the central angle is less than 180 degrees. Then what is a minor arc is the distance around the circle from point E to point G. Okay? So if the measure of the central angle, angle EAG, is less than 180, then E and G and the points on the circle on the interior of angle EAG. So what is that all about? Well, what that basically is saying is that if you have E and G and their points on the circle, and you have the interior of the angle, and the interior of the angle is anything between those points, between those sides, anything out here. Well, wherever that hits the circle, anywhere that color hits the circle, this is your minor arc. So this has to be less than 180. There is another minor arc. That one is B to E. B to E is a minor arc because this angle is less than 180 degrees. If I connected A to C, okay, if I connected this, then arc BC is also a minor arc because this angle BAC, so the measure of angle BAC is less than 180 degrees. Okay? Now, how we write arcs is if you notice that little handwritten kind of arch over top of it, that is the symbol. So it's going to be an arch. You're going to name the 2 points that are on the circle inside the interior of that angle. So for example, if I had BC, we know that that's the length. Also, we have the segment, we have a ray, we have a line. We now have an arc. So this is arc BC. We have segment BC, we have arc BC. You got it, right? All right, a major arc is points E and G and the points A on the exterior of EAG. So if EAG, if the measure of the EAG is greater than 180 degrees, then it's going to be a major arc. So where's the major arc? The major arc comes into play. We're going to look at the other one. So EAG, the arc, the points E and G and the points that are on the exterior. So everything that's not shaded blue is the exterior. So this, oh, my steady hand drawing backwards, is my major arc. Okay, so my green, let me write it in green. I didn't write that in blue. All right, so my major, whoops, spell it right, is BCE. Nope. Nope, not that one. It could be, but it's not. In this one, it is EBC. And no, that is not correct either. Sorry. I'm going to get away from green because green's causing me troubles. If we start at E, so major arc, sorry, we're going to start at E, and we got to end at G. We got to end at G. So someplace in between we have to go through. If we just went E to G and named it with 2 letters, we'd have a minor arc. If I start with E and go the other way, I either have to name B or C. I can name that one. It's the arc. It's the major arc. Notice major arcs have 3 letters. Minor arcs have 2 letters. So there is another major arc, BCE. So if I start at B and go through C and go around to E, it's this one that hits that one. Okay? So that is another major arc. Major arcs are greater than 180 degrees. We'll talk about measurements probably on Monday, next Monday. And the semicircle, the endpoints of the arcs are the endpoints of a diameter. So we know our diameter is B to G. So a semicircle is going to go from B to G, and we need a letter in between. We can, it's okay. We can go this way or we can go this way, but if we want to look directionally, does it go through C or does it go through E? It doesn't matter. So these are your endpoints of your diameter. Okay. All right, naming arcs. Arcs are named by their endpoints. The minor arc associated with central angle, well, this H is angle MHL. H is your center. So the 2 endpoints are going to be the endpoints of your arc. So what we need with a major arc is we need, I don't have a picture here, so we can't answer those right now. Forgive me, but that's okay. We'll get to those. All right, last page, talking about tangents. Here are all the common tangents. And then down here are some circles. All right, tangent circles are coplanar, same plane circles that intersect at one point. Same plane circles that intersect at one point. Oh, well, there's no examples of circles that intersect at one point here. So let's see if I can draw some. That's pretty good. And that is not very good. So they intersect at one point, like a snowman. Or you could have this circle, and then you can have this circle inside of it. Okay? So that are tangent circles. They intersect at one point. This one point, yes, it's over-exaggerated. All right, concentric circles, if you remember, you did that in your scavenger hunt. They have the same center, so think of a target, a bullseye, whatever. They are circles with the same center. A common tangent, I need a piece of paper underneath because I can't write on the wood with this. A common tangent is a line or segment that is tangent to 2 coplanar circles. So let's look at A down here. So A would be this line. Here is a common tangent. So it's going to be tangent not only to M, but it's going to be tangent to K as well. So A is a common tangent. It is a line or segment that is tangent to 2 coplanar circles. 2 circles on the same plane. A common internal tangent is a tangent that intersects a segment that joins the centers. Oh, so I just drew the common internal, sorry. So this would also be B. We're going to call this one B. The common internal joins the segments. Okay, so it intersects the segments. And a common external, which is the next one, is going to be a tangent, a common tangent that does not connect. So this is C. So this part is C. So common external, a tangent that does not intersect the segment that joins the centers. So there's my segment that joins the centers, KM. This is my common external tangent. There's a common interior tangent. And both of them, I guess I could put an A there, are common tangents. Okay? Interior of a circle, any points that are inside the circle? Exterior, any points on the outside of the circle? Any points on the circle is the circle. And a point of tangency is the point at which the tangent line intersects the circle to which it is tangent. Okay, so notice in this one, if I connect these two right through there, that's not a tangent, that's a secant. So I don't know why I put that on there, but that would be a secant because it hits the circles at 2 points. What I was thinking I was doing is probably drawing my tangents, my common tangents out here and my common tangents out there. Okay? All right, so let me get you started on your homework. You have this, so you're using that picture to name what those are, points, chords, secants, tangents, major arcs, minor arcs. Remember, major and minor. Major arcs have 3 letters. And you go big around the circle. A minor arc has 2 letters. And it's small. Less than 180. And a semicircle is 3 letters, sometimes 2. And it goes with the diameter. Okay? So I want you to do that one. And I want you to do this using that picture. C is the center. Find if AE is a minor, major, or semi. Well, I'll go over the first one with you. A to E. Well, ACE. So we look at ACE because we're always going to look at the center of that. We're going to call this 2 letters. This is a minor arc. Okay? So that packet, finish up that packet if you can. You have your scavenger hunt, and I do believe there will be either a quizzes or a Kahoot. I haven't decided yet, but we're looking at definitions right now. And then on Monday, starting Monday, we're going to go into the measurements of it. And I think we'll spend 2 or 3 days on that, so that next Monday and Wednesday will be angle measures, and then we're going to start on area of figures and volumes and surface areas and all that good stuff. Okay, Mr. Brayman's chomping at the bit to get to me to talk about Algebra 3. So, have a good day. Have a good rest of the week. If you do have any questions, let me know. Again, tomorrow, starting at 10:40, we have first hour for 20 minutes. Wait 10 minutes. At 11:10 will be 4th hour. At 11:30 that will end. At 11:40 we'll have 6th hour, and that will go to 12 noon. And then if you need any help with anything else after that, you can set up a Calendly event, or you can just say, hey, I need to talk to you, and I will set up a Google call with you. All right, so have a good day and have fun learning about circles. If you can't figure it out, there's plenty of videos. I can help you out. But try other objects, other outlets, YouTube, Google, whatever, before you come back to me, okay? All right. Have a good whatever time of day that you're having. See ya.